Hi guys. In this video, we are going to analyze the concept of exponents. And just to refresh your memory about what an exponent is, we are going to use the term 7x squared. In this case, the 7 would be the coefficient. And remember, the coefficient is the number that scales the variable. This little 2 at the top is known as the actual exponent, or index is another word for exponent. And this number tells us how many times we need to take this number and multiply it by itself. This number being an x, which is known as the base. Remember, in exponents, we are always concerned with an exponent and a base. And exponents follow various laws. And in this video, we're going to analyze two of those laws. So let's take a look at the first one. The first law says that if you take a base, which is raised to a certain power, and you multiply it by the same base, which is raised to a different power, the resultant number will be that base raised to the power of the summation of these two numbers. So pretty straightforward, nothing too complicated there. If we just had to look at a quick example, let's say for argument's sake, we have an x squared, and we multiply that by an x to the power of 3. Well, this is the same as saying x times x, that would be our x squared, times, remember another way to represent multiplication is a dot, times x times x times x. So 1, 2, 3 would be our x cubed, and these two would be our x squared. Well, I can go ahead and count these. 1, 2, 3, 4, 5. Therefore, my answer would be x to the power of 5. Or I could use my law and say that it is x to the power of 2 plus 3. And that's a direct use of the first law of exponents. Let's go ahead and take a look at the second law. And the second law is exactly like the first. Instead of dealing with multiplication, we're dealing with division. And the second law states that if we have an x raised to the power of an m, and we divide it by an x raised to the power of an n, the resultant number is the same base as before, but this time we are going to minus the exponents from one another. Now, in algebra, it's very rare to use the division sign, and you're probably going to see a lot more of this instead of that division sign. We would rather rewrite this expression like this in a fraction form. And this would lead to the exact same scenario. It would be the numerator's exponents multiplied by the denominators. Order is very important in this case, as subtraction does not follow the commutative law. Let's go ahead and take a look at a solid example with this specific law. If we had an x raised to the power of 6 divided by an x raised to the power of 2, the resultant number would simply be x to the power of 6 minus 2, which would give us an x to the power of 4. Now we can use these two laws to simplify complicated algebraic expressions. Let's take a look at a few examples. So if we look at the first example, we have an x squared multiplied by an x cubed multiplied by a y squared all over x times y. Now what I like to do is I like to make sure that our numerator and denominator is fully simplified before I move on to any other form of simplification. What I mean by that, well, if I look at the numerator, I have an x squared and an x cubed. Now, I can apply the first law of exponents to this scenario, and that would leave me with an x. 2 plus 3 would be 5. Carry our y squared. Over x times y. Now I can move across the division symbol now that our numerator and denominator are fully simplified, And we can go ahead and apply the second law of exponents. And the second law said that when we divide by the same base, we just need to minus the numerator's exponents by the denominators. Remember, if a number does not have an exponent next to it, it is assumed that that exponent is a positive 1. Therefore, the answer to this would be an x to the power of 5 minus 1, 5 minus 1, multiplied by y to the power of 2 minus 1. And my final answer would be x to the power of 4 times y to the power of 3. Let's go ahead and take a look at the second example. We have 15x to the power of 4 times y cubed all over 5x cubed y squared. So what I would prefer to do in this example is to immediately simplify the exponents. The coefficients before I would do anything. And the coefficients in this case would be the 15 and the 5. So I would simply pull those one side and simplify them on their own. Well, 15 divided by 5 would be a 3 over 1, or simply a 3. Now I can go ahead and simplify the bases using the second law of exponents, which would leave me with x to the power of 4 minus 3 times y to the power of 3 minus 2. Well, 3 over 1 is simply 3, multiplied by x to the power of 1, multiplied by y to the power of 1. You can put the 1 there. It doesn't make a difference. In my next video, I will be covering the third and fourth law of exponents. So I thank you for watching, and please stay tuned.